This lesson will explain how to calculate the energy change of a chemical reaction that you might find in the Science 30 course. We're going to use Hess's Law for this, and this is one of the nastiest looking formulas you're going to see in Science 30. But when we actually see how it's done, it's not that bad. It's a nasty looking formula because all the symbols involved. First off, what we've got in Hess's Law is this symbol right here means the change in energy of the reaction. That's the ultimate goal of our calculation. Just trying to find that delta RH, the change in the heat or the energy level of a reaction. Now, that's equal to, well, we have to use these fancy symbols, the Greek letter epsilon here, which just means the sum or the addition of. We just have to add up the heats of formation, that's what this is, the heats of formation of all the products times the number of moles of each of those products, which we can just get from a balanced chemical equation, which in Science 30 is always going to be given to you in a question on an exam. If you're in another science course, well, your teacher may want you to write that balanced chemical equation. Science 30, you don't have to do that, it's always given. So we have the number of moles times the standard heat of formation times of the products. Then we have to do the same thing for reactants. We take the sum of all of the heats of reaction of all the reactants times their number of moles. So the easiest way to do this is just to do an example of it, because once you see an example done, it's not that bad. Again, you're given the balanced chemical equation. And there's something else that is a nice little feature in Science 30 is that you're always going to be dealing with 1 mole of whatever substance is reacting. So that makes it, again, a fairly straightforward calculation. So let's take a look at an example of combustion of propane. We want to figure out the heat of the reaction of the combustion of propane. Well, we have to start out with a balanced chemical equation. Again, in Science 30, this is going to be given to you, but propane is C3H8 gas, plus, if we're burning anything, we're adding oxygen gas to it. And we are assuming a 100% complete combustion here. That's another thing in Science 30. They're always going to assume 100% complete combustion, which means we have only 2 products we need to worry about. And that's carbon dioxide gas plus water vapor. All right, so we need to balance this chemical reaction. Again, it'll be balanced when you do it on a Science 30 exam, but for any other students out there watching this, to balance the reaction, we always start with combustion reactions of hydrocarbons with the carbons. So we see 3 carbons on the reactant side, so we need to put a 3 for the carbons on the product side. Next, we would do the hydrogens. We have 8 hydrogens on the reactant side, so we would need 4 times 2 to make 8 hydrogens on the product side. Now, we'll take the oxygens on the product side. We'll work backwards here. We've got 3 times 2 makes 6 oxygens, plus 4 times 1 is 4 more. 6 plus 4 is 10. Because they come in groups of 2 on the reactant side, we would just need 5 times 2 to make that chemical equation balance. Again, Science 30, that's going to be done for you. All right, so with the balanced chemical equation, we can now do the calculation. So what we need to do is we need to find out, well, what are the heats of formation, right here, the heats of formation of the products. And that we need a reference material for. So Science 30, you'd have a data booklet. Other science courses, you might have to look that up in your textbook or the dreaded handbook of chemistry and physics. But you have a way to look that up. You don't have to memorize that. So here we have a table that you would find on a Science 30 test. And it has the standard heats of formation of many different substances. Now, a couple things to notice is there is the unit, kilojoules per mole. We're going to have to pay attention to that unit. Another thing to notice is that some of these are negative values and some of these are positive values. Well, it does tell us down at the bottom here, little notes. What does it mean to be negative or positive? Well, negative means it's exothermic, so energy is going to be released in the chemical reaction. A positive sign tells us that it's an endothermic change. That means energy is going to be absorbed when these substances are formed. The last thing we have to look at here is the other note, very important note, is that elements are given a value of 0. And the reason that's important is in a combustion reaction, there is an element involved in that chemical equation. The element is oxygen, which means the heat of formation of oxygen is 0. We can ignore it in our calculation, and that's a good thing. We don't have to worry about that. Now, doing this problem, I can see propane right here. Propane is negative 103.8 kilojoules per mole. I know it's kind of small, it's hard to read there, but negative 103.8 kilojoules per mole. We're going to need that number for our calculation. We are also going to need carbon dioxide. And carbon dioxide we have right here. It's negative 393.5. And we're going to need water. Now we have to pay attention to the state of water in our chemical reaction equation because it's different if it's stated as a liquid or as a gas. So always pay attention to that state. In our particular reaction, it was H2O gas, so negative 241.8. So those are the numbers we're going to need from this table. And we're going to have to go back and reference that as we do our problem. So here we go. We're now going to get into the calculation. So we're going to start with our products, and our products are CO2 and H2O. So what we need to do is we need to add up all of our products. So the first product we have here is 3 moles of CO2. So what I'm going to need to do is I'm going to have to multiply by 3 the heat of formation of carbon dioxide, which we looked up in the table earlier. It was negative 393.5 kilojoules per mole. Now, if you have to go back to the table and look that up, obviously you probably don't remember it, but that's what we looked up in the table. Now we have to add to that the 4 moles of H2O. You know, 4 moles of H2O gas. Remember, it was gas here, so that made a difference. So we would go plus 4 times, and for water vapor, H2O gas, it's negative 241.8 kilojoules per mole. We just look that up off the table. So we add those together. So let me just pause while I calculate this. All right, so after calculating, we find that our product side of the equation comes out to negative 2,147.7, and our unit is kilojoules per mole. All right, so that is our product side of our equation. So we've now completed this part of our formula. Now we need to do this part. And this part is actually going to be pretty straightforward because in all of the questions you get in Science 30, it's always going to be 1 mole of our reactant. There's no 1 in front of here. We have to remember when there's no number in front, no coefficient. That means we have 1. So we just have 1 mole of C3H8. And we don't need to worry about how many moles of oxygen we have because oxygen is an element and elements have a heat of formation of 0. So it's not going to factor into our calculation. So if we do the reactant side of the equation, so minus this, we're going to subtract now some of all of our reactants. We're going to have 1 mole times, for carbon dioxide, for propane, C3H8. C3H8 is, I just have to look it up off my table again, and it is negative 103.8 kilojoules per mole, and of course 1 times anything is just itself, so this will just be negative 103.8 kilojoules per mole. So to get our final answer, we take this number, subtract this number. Keeping in mind, this is a negative number, so subtracting a negative is the same as addition. So I just need to take my previous answer and add to it 103.8, and I get a final answer. This is equal to negative 2,043.9 kilojoules per mole. And there we have our final answer of our calculation. Now, here in Science 30, that's all there is to it. It looks like a complicated formula. It's not that difficult when you're able to look up all those values off the table. And when we're dealing with 1 mole of whatever substance it is that we're reacting. Now, you can stop listening here if you're in Science 30. If you're in any other chemistry course, things would get more complicated if you had to calculate the number of moles of the initial substance. If we have to figure out how much propane there was, for example, you might be given the number of grams of propane. Well, then you'd have to use an appropriate formula of number of moles equals mass over molar mass to determine the number of moles. Then you need mole ratios to figure out, well, if you have less than 1 mole or greater than 1 mole of the propane, then how many moles are you going to get of the carbon dioxide, and how many moles are you going to get of the water vapor. You might be given the volume and temperature and pressure of the gas of the propane. If you're given volume, temperature, and pressure, you're going to have to use gas laws to figure out the number of moles, and then use mole ratios. So it does get more complicated than this, but for Science 30 students, this is all you're going to have to do on your test.